Have you ever wondered, will the universe end someday? The answer is yes. However, the real question is, how will it end? That is what we will be exploring in this video. Hello and welcome to my channel Beyond Earth, your portal to the cosmos. The universe is so vast that it is hard to imagine a catastrophe big enough to affect the entirety of existence, but physicists do expect it all to end at some point. Here are some of the leading hypotheses about how the universe could end and when. Before we start with the hypothesis, let's start from the beginning. About 13.8 billion years ago, space and time burst forth from an incredibly dense singularity, an event that's come to be known as the Big Bang. From that point on, the universe has expanded and it continues to expand at an accelerating pace thanks to a mysterious force that scientists call dark energy. In fact, there is a constant tug-of-war between gravity and dark energy, and the fate of the universe depends on who wins. This leads us to the first scenario. According to our best models of the evolution of the universe, the most likely scenario is what's called the Big Freeze. In this scenario, dark energy keeps accelerating the expansion of the universe forever. The cosmos will die a slow death that will be drawn out for a Google years. That unfathomable number is a 1 followed by 100 zeros. The distant stars and galaxies will keep getting away from us until their light can't reach us. About 100 trillion years from now, only white dwarfs, neutron stars, and black holes exist, but these too will fade. White dwarfs and some neutron stars will slowly cool into invisible, inert black dwarfs, while other neutron stars will collapse into black holes. By the year 10 tridecillion, A1 followed by 43 zeros, there won't be anything but black holes left. And even these aren't eternal. As Stephen Hawking predicted, black holes slowly give off radiation until they eventually evaporate. The only thing that will remain will be the black dwarfs. Some estimates suggest they have a lifespan of 10 to the power of 1100 years, that is 10 followed by 1100 zeros. That is a very long time. If you find this scenario boring, then the next scenario is definitely for you. A similar scenario as the Big Freeze, however, in this case, dark energy won, and now the universe is expanding exponentially, eventually tearing the very fabric of reality apart. In this model, the universe could tear itself apart in 22 billion years. In the Big Rip model, the exponentially accelerating expansion pushes more and more objects away, meaning that the observable universe is constantly shrinking. As that distance shrinks, gravity's influence weakens, it won't be able to hold galaxy clusters together, and they'll start dissolving. Eventually, the same will happen to the galaxies and later on to the individual star system, meaning stars and planets will float freely away from each other. In the final few minutes, dark energy will overcome the force which holds the molecules together, shredding stars, planets, and everything on them. And finally, those loose atoms themselves would be ripped apart, particle by particle. The last victim is the fabric of space-time itself. Pretty dramatic way to go, however. Don't worry. Scientists believe that this scenario involves parameters that aren't realistic, so is less likely to occur than some of the other ideas on this list. The next two scenarios could answer the question, what was there before the Big Bang? But the real showstopper, the one you absolutely wouldn't want to miss, is the final scenario. So buckle up, because the next few minutes are going to be a wild ride through the wildest endings the universe could conjure up. Next up is Big Crunch. In this scenario, gravity wins and the universe ends in the opposite way. Instead of expanding forever into nothingness, it changes course and collapses in on itself in a so-called Big Crunch. Everything will begin to move towards everything else as the universe shrinks once again. Galaxy clusters would start to merge, then galaxies themselves, and eventually individual stars would collide more regularly. As the universe keeps shrinking, it keeps getting hotter. In the last few minutes, the temperature of the universe would be so extremely hot that atoms themselves fall apart. Eventually, the entire contents of the universe will be crushed together into an impossibly tiny space, a singularity, like a reverse Big Bang. You would think this will be the end, but a variation on the above hypothesis suggests that moments before the universe collapses into an infinitely dense singularity, it's saved by quantum processes and reverses course once again, beginning a new period of expansion that's effectively another Big Bang for a brand new universe. This model is known as the Big Bounce. As the universe shrinks towards a singularity, it becomes so small that quantum rules take over from the large-scale classical physics we're familiar with. At that point, quantum tunneling can occur, which drives processes like radioactive decay and, according to a recent study, could also allow a contracting universe to escape the fate of total collapse and begin expanding again. The fun implication of the Big Bounce hypothesis is that we might be in the middle of a never-ending chain of universes being created and destroyed. But what if, in the tussle between gravity and dark energy, a third contender puts his hat in the ring? The final Doomsday scenario could be the most unsettling, because it could already be barreling down on us, and we wouldn't know until it hit. It's called the Big Slurp. It's a law of physics that a system will naturally try to move from a state of high energy to one with lower energy until it stabilizes into its lowest possible energy state. For quantum fields, this is known as its vacuum state. All known quantum fields are in their stable vacuum states, except for the Higgs field. Yes, it is the same Higgs field that was confirmed after the discovery of the Higgs boson. It seems to be in a false vacuum state, which means that it currently appears stable, but that could change without warning. All it would take is for one tiny point in space to collapse into this lower energy state, which would send a bubble of vacuum decay expanding outwards at the speed of light. Moving that fast, we couldn't even see it coming until the wall of that bubble slammed into Earth. What happens inside that bubble, nobody knows. However, the good news is that there's a lot of uncertainty to the idea. Also, the Higgs field is more stable than it is given credit for. So there you have it, folks. 5 mind-blowing ways the universe could meet its maker. But hey, at least we can all agree on one thing. The universe is a pretty amazing place, even if its ending might be a bit dramatic. Like and subscribe for more cosmic adventures. Share your thoughts on the end of the universe in the comments below. Let's explore the universe together and unlock its secrets.